तो ट्रांजिएंट में एक ये जो एग्जाम्पल है, जो किसी न किसी के साथ कभी न कभी जरूर घटना घटित होता है कि आपने की को ऑन किया और बल्ब फ्यूज हो गया। बल्ब फ्यूज हो गया। बल्ब फ्यूज होने के बहुत सारे कारण हो सकते हैं, लेकिन हम जो कारण यहाँ पे बता रहे हैं कंडीशन, वो की ऑन के समय, की ऑन के समय
क्लास है।
है ना, की ऑन के समय ये घटना घटित होता है। तो वो क्यों होता है, इस चीज को हमें स्टडी करना है। अब जो सर्किट होता है, यदि सर्किट की बात करें तो सर्किट स्टेट।
सर सबको म्यूट कर दीजिए, वॉइस आ रही है बहुत।
अच्छा,
यस सर।
ओके, 100 पार्टिसिपेंट्स हो भी गए। और हाँ, तो सर्किट का जो स्टेट होता है, उस स्टेट को हम दो भागों में डिवाइड कर सकते हैं। एक हो गया ट्रांजिएंट स्टेट, ट्रांजिएंट स्टेट, और दूसरा हो गया स्टेडी स्टेट। स्टेडी स्टेट है ना, ट्रांजिएंट स्टेट, स्टेडी स्टेट। तो ट्रांजिएंट स्टेट में भी दो पार्ट हो गया। एक हो गया ऑन टाइम, दिस इज ऑन टाइम, और दूसरा हो गया ऑफ टाइम। दूसरा हो गया ऑफ टाइम। ऑन टाइम में क्या होता है, ऑन टाइम में एनर्जी स्टोर होता है। एनर्जी स्टोर है ना, किस फॉर्म में, इलेक्ट्रिकल फॉर्म, इलेक्ट्रिकल फॉर्म और मैग्नेटिक फॉर्म। इलेक्ट्रिकल फॉर्म या मैग्नेटिक फॉर्म आर बोथ, इलेक्ट्रिकल और मैग्नेटिक दोनों फॉर्म में स्टोर हो सकता है। ठीक है, तो आप ये कह सकते हैं कि एनर्जी बिल्डअप होता है, एनर्जी बिल्ड अप। ठीक है, एनर्जी बिल्डअप का मतलब, मान लीजिए ये कोई कंटेनर है ना, ये कंटेनर है, इसके अंदर कैपेसिटी है, तो यहां से जब एनर्जी इसमें रखेंगे तो बिल्डअप का मतलब कि स्टोर हो रहा है। ये ऑफ टाइम का मतलब होता है एनर्जी जो स्टोर था वो एनर्जी क्या होगा, रिलीज होगा। एनर्जी रिलीज, जो एनर्जी रिलीज होगा, कौन सी एनर्जी रिलीज होगा, इलेक्ट्रिकल एनर्जी या मैग्नेटिक एनर्जी या बोथ, जो भी एनर्जी है वो रिलीज हो जाएगा। और एनर्जी बिल्ट के जगह पर एनर्जी डीके होगा, एनर्जी डीके, एनर्जी डीके अवे फ्रॉम द सर्किट। और आप इसको बनाना चाहते हैं तो यू कैन ड्रॉ दिस काइंड ऑफ, कि ये एनर्जी है, ये डीके हो गया, दिस कंटेनर, और ये एनर्जी चला गया, डीके अवे हो गया। तो ये तो कॉन्सेप्ट हो गया ट्रांजिएंट का। व्हाट इज द स्टेडी स्टेट? स्टेडी स्टेट मतलब नो चेंज, नो चेंज विथ respect of time, with respect of time, no change in respect of time, study। ठीक है, तो यदि हम IT लिख दें, IT करंट के लिए, तो दिस इज कांस्टेंट। करंट के लिए IT कांस्टेंट, तो इसको हम कहेंगे I0, है ना। या वोल्टेज के लिए कह दें VT ये भी कांस्टेंट होगा, तो वी कॉल्ड इट इज V0, I0 V0 स्टडी स्टेट। अब इसको यदि हम ड्रॉ करें, है ना, ड्रॉ करें तो ये जो ड्रॉ होता है ये इस तरह से दिस वन इज द स्टेट। तो इसके 3 पार्ट हो गए। यहां से जो पार्ट है अप टू दिस पार्ट ये ऑन टाइम हो गया, दिस इज योर ऑन स्टेट। और यहां पर जो हो गया दिस इज योर ऑफ स्टेट, ये ऑन स्टेट और ये ऑफ स्टेट, और ये हो गया स्टडी स्टेट, दिस इज योर स्टडी स्टेट। तो एक सर्किट में क्या हो गया, देयर आर 3 स्टेट। फर्स्ट ऑन स्टेट जिसको हम यहां से डिनोट करते हैं ऑन टाइम का ऑन स्टेट, और दूसरा हो गया ऑफ स्टेट, दिस इज योर ऑफ स्टेट, एंड थर्ड वन इज स्टडी स्टेट, सो दिस इज स्टडी स्टेट। तो यहां पर यदि ये टाइम है, x is time, y can be represented as IT or VT, माने करेंट का वेरिएशन चाहे वोल्टेज का वेरिएशन ये हो सकता है। तो ये तो एक सिंपल कॉन्सेप्ट हो गया ट्रांजिएंट का, है ना, ट्रांजिएंट का और सर्किट से स्टेडी स्टेट का भी, ट्रांजिएंट का और स्टेट का। अब जो मेरा मेन क्वेश्चन है कि बल्ब फ्यूज क्यों हुआ, फ्यूज ऑफ बल्ब एट स्विचिंग ऑन स्टेट में, ऑन स्टेट में बल्ब फ्यूज हो रहा है। इसका मतलब हो गया कि ये टाइम है, तो ये स्टेट, दिस स्टेट, दिस इज ऑन स्टेट, इस पॉइंट पर बल्ब फ्यूज हो गया। अब इस पॉइंट को एनालिसिस किया जाए तो ये जो होगा ये इस तरह से, ठीक है, ये जो होगा इस तरह से, या हम इसको यदि दूसरे लाइन से कलर से डिनोट करें तो ये ऐसे भी हो सकता है, ऐसे, ठीक है। तो ये 3 का जो ग्राफ है इसमें क्या अंतर है ना, इसमें क्या अंतर है, इस चीज को ध्यान से देखना है। इसके लिए यदि हम ये कह दें दिस इज थर्ड कर्व, तो ये हो जाएगा सेकेंड कर्व, और ये हो गया फर्स्ट कर्व, है ना, फर्स्ट कर्व। इन तीनों को ध्यान से देखना है तो हमारे क्वेश्चन का आंसर मिलेगा कि क्यों बल्ब फ्यूज हुआ। बल्ब फ्यूज होने में, अब फिर से यदि उसको हम बना दें, जो घटना घटित हुआ कि बल्ब पहला था ये केस एक ऑन टाइम, दिस इज योर ऑन टाइम, टी ऑन। दूसरा हो गया ये, दिस इज योर सेकेंड केस। थर्ड हो रहा है ये, थर्ड केस, दिस इज योर सेकेंड एंड दिस इज योर फर्स्ट। अब आप ये देखिए कि कोई एक्सप्रेशन है see current is function of time. Current is function of time. तो चेंज क्या हो रहा है? फर्स्ट स्टेट में di over dt, सेकेंड स्टेप में, if you call second here, di by dt, थर्ड में di by dt, di by dt. करंट का वेरिएशन, करंट का वेरिएशन, यदि हम तीनों केस में करंट का वेरिएशन निकालें तो क्या मिलेगा? व्हाट वी फाइंड, यदि ये कह दें कि दिस इज थीटा, तो दिस थीटा इज इक्वल टू 10, है ना? थीटा इज इक्वल टू 10 जो भी वैल्यू होगा, एंड इट इज कॉल्ड एज ग्रेडियंट. इट इज कॉल्ड एज ग्रेडियंट या स्लोप, gradient or slope. So if we call this gradient, theta is tan inverse of this, that is called gradient, and m. So if we say this is m1, this is m2, and this is m3. So this part is m1, here it is m2, and this is your m3. So what we find, m1 is less than m2 is less than m3. m1 is less than m2 is less than m3. ठीक है? नॉर्मल ये जो टाइम है, दिस t on, this t on depends on the components, depends on the component used in the circuit. जो सर्किट में आपने कंपोनेंट यूज किया है उसके ऊपर निर्भर करता है. तो फ्यूज के लिए चांस यदि हम कहें, प्रोबेबिलिटी P1 of M1, probability P of M1 is less than probability M2 is less than probability M3. मतलब क्या है कि यदि फ्यूज होने की प्रोबेबिलिटी of fuse during on time, माने जब बल्ब आप जला रहे हैं तो उस समय बल्ब फ्यूज होने की प्रोबेबिलिटी क्या है? हमने कहा ना कि हमेशा नहीं होता है, कभी कभी होगा. कभी कभी होने का मतलब कि यदि ग्रेडियंट कम है तो प्रोबेबिलिटी कम होगा, यदि ग्रेडियंट ज्यादा है तो प्रोबेबिलिटी ज्यादा होगा. di over dt, रेट ऑफ चेंज ऑफ करंट, रेट ऑफ चेंज ऑफ करंट. तो रेट ऑफ चेंज ऑफ करंट यदि बहुत ज्यादा होगा तो रेट ऑफ चेंज ऑफ करंट को हम कैसे डिफाइन करेंगे? मान लीजिए ये कॉइल है, सपोज दिस इज ए कॉइल, इंडक्टर है ना, L, और L के साथ di over dt हो गया, रेट ऑफ चेंज ऑफ करंट. ये क्या दे देगा? दिस इज द वोल्टेज, मीन्स वोल्टेज VL इज L into di over dt. तो जिस स्टेट का, जिसका ग्रेडियंट जितना ज्यादा होगा उसका वोल्टेज उतना ज्यादा होगा. तो V3 कौन होगा? M3 का is greater than V2 of M2 is greater than V1 of M1. मतलब यदि इसका हम ग्रेडियंट निकाल करके वोल्टेज कह दें V1 है, ये वोल्टेज V2 है और ये वोल्टेज V3 है, तो V3 of M3 is greater than V2 of M2 is greater than V1 of M1. So this one is induced voltage. इस वोल्टेज को क्या कहेंगे? This is induced voltage. Induced voltage. तो फ्यूज होने का कारण क्या है? Induced voltage. Cause of fuse is induced voltage. Induced voltage. तो जितना तेजी से आप इसको स्विच ऑन करेंगे उतना ज्यादा इंड्यूस्ड वोल्टेज डेवलप होगा और उतना ही ज्यादा चांसेस हैं बल्ब के फ्यूज होने से। तो ये जो क्वेश्चन है दिस इज बेस्ड ऑन द ट्रांजिएंट फिनोमेना, सोर्स वोल्टेज का नहीं है, माइंड इट। It is not concerned with the source voltage. It is always concerned with the switching speed, है ना? During the fuse होने के टाइम पर ये हो जाता है और उसके इंड्यूस्ड वोल्टेज है, वो इंड्यूस्ड वोल्टेज के लिए ये काम करते हैं। तो ट्रांजिएंट को यदि हम क्लासिफाई कर दें तो 3 क्लास बनाते हैं। जैसे पहले हम आपने कहा कि ट्रांजिएंट ऑन टाइम, transient on time. What is transient on time? When the source is switched on, the process of energy storage starts and the circuit voltage and current build up gradually का मतलब ग्रेडियंट से, that is slope, है ना, rather than instantly, है ना। This is your transient time. और transient off time, transient off time क्या है? When the source is switched off. This is switched off, here it is switched on, switched off, the energy store in the component जैसे मान लीजिए इंडक्टर है तो उसमें मैग्नेटिक एनर्जी स्टोर है, और कैपेसिटर है तो इलेक्ट्रिकल एनर्जी स्टोर है। दिस इज इलेक्ट्रिकल एनर्जी स्टोर है। components, the energy stored in the component is gradually released, and it does not permit the circuit voltage and current to drop down to zero instantly. तुरंत जीरो नहीं होता है. तो first is the transient on, second is transient off, and third one is steady state. Third one is steady state in the circuit. When the energy is fully stored, the circuit voltage and current, do not change with respect to time. With respect to time. And it is said to be steady state. And it is said to be in steady state. So these are the basic concept of the circuit, which are the transient state or steady state. Now the growth time is, switching time is the growth of energy. So we can take the growth of current and voltage. Growth of current and voltage. तो मान लीजिए एक सर्किट एलिमेंट है, ये है इंडक्टर और ये है रेजिस्टेंस. ये दो सर्किट एलिमेंट है और यहां पर दो स्विच लगा हुआ है और दिस वन इज ए पॉइंट. सो दिस पॉइंट इज 1, 2, 3. This point is 1, 2, 3. So if it is connected with 1, this is L and here it is R. So two components L and R are connected to the circuit. As soon when point 3 is connected to 1, then it is on. Then it is on. On means switch on. Switch on. Yeah, on means switch on. So what happened? The current I of T will flow, and this potential say this is positive potential, here a negative potential, and a voltage VL generate. Here it is positive potential, this is negative potential, this voltage is generate. So the potential develop across the components are VL is L di by dt, VL di by dt, and VR is equal to RI, and here it is the applied voltage. So using Kirchhoff voltage law, Kirchhoff's voltage law, that is KVL, we have what we have, VL plus VR minus V is equal to 0. This is plus, this is minus, this is plus, this is minus, and here it is minus and then plus. So what is VL? This is L di by dt plus RI minus V is equal to 0, or L di by dt is equal to V minus IR. This is V minus IR. So we can have this one is equation 1, and here it is equation 2. Now we take the separable of variable, separable of variables as L di by dt is equal to V minus IR. So this part is the current part, and here it is the current part. So what happened? This is di over V minus IR. This is the variable of the current, and here it is L. This is dt by L. This is dt by L. Now this one is integrating this equation. Integrating this equation 4, we have what we have. This is di V minus IR. This is dt upon L. So this implies log V minus IR with minus 1 by R is equal to T by L plus A. A is constant of integration. A is constant of integration. A is constant of integration. Boundary condition. Our initial condition. When T is 0, I is equal to 0. And T is 0, I is equal to 0. This is equation 4. So from equation 4, we have log V minus this I is 0, 0 R minus 1 by R is equal to T0 by L plus A. So this is log V, and here it is minus 1 by R is equal to A. A is equal to minus 1 by R log, this is log base E. This is log base E. So substituting the value of A in equation 4, we have minus 1 by R. This is log V minus IR is equal to T by L minus 1 by R log A, log V. This is log V. This is log V, log base E. So what we find, if we transfer this, that is 1 by R log base EV minus IR minus 1 by R log V is equal to minus T by L. So 1 by R common, 1 by R common. So it is log E base V minus IR minus log V is equal to minus T by L. R 1 by R, this is log M minus M. So M by M, it is V minus IR upon V is equal to minus T by L. Or log base E 1 minus IR by V is equal to minus RLT. RT. Or taking anti-log, anti-log of both sides, we have 1 minus I R by V is equal to E raised to the power minus R by LT. This is R 1 minus, that is IR, that is 1 minus E minus R by L T is equal to I R by L. Or I of T is equal to L by R this is V. Here it is V. Now when t tends to infinity, long time. When t tends to infinity long time, e raised to the power minus r L into t is equal to e raised to the power 1 upon r L into t. That is 1 upon infinity, which is equal to 0. That is equal to 0. So I of t tends to infinity is equal to v by r, and this is nothing but I0, say peak value. Peak value. So we have IT is equal to I0 1 minus e raised to the power r by LT. This is equation 5. This is equation 5. This is equation 5. Now take the dimension. Now take the dimension of R by L. R by L, that is ohm by Henry. This is ohm by Henry is voltage. Henry is voltage, and ampere current. So this is R by L is ohm ampere upon voltage into second. That is voltage upon voltage into second. So this is cancelled. Here it is second. Inverse R by L. Yeah, L by R is second. It is time. So L by R is the dimension of time. So it is the time. And then defined as L by R is dimension of time. Then it is defined as time constant. It is defined as time constant. And represented by tau. Tau from Greek letter. Greek letter tau. The equation IT is equal to I0 1 minus e raised to the power minus t upon tau. T upon tau. So this is equation number 6. When t is equal to tau, then e raised to the power minus t upon tau is equal to e raised to the power minus 1. That is 1 upon e. That is 1 upon 2.73. 1 upon 2.73. That is 0.367. So from equation, IT is equal to I0 1 minus 0.367 is equal to 0.632 I0. 0.63 I0. This I of t is equal to 632 I0 when t is equal to tau. And also I t is equal to 0.9933 I0 when t is equal to 5 tau. T is equal to 5 tau. What is the meaning of this one? Means the current approach steady state value I0, steady state value I0 asymptotically at 5 tau. Thus, theoretically speaking, the current reaches steady state, only after an infinite time. Only after an infinite time. So we can plot this one. No, we can plot this. That is graphs. The plots of current for various values of taus. That is tau 1 and tau 2. This is time. Here it is IT. This is I0 current, and this curve is something like this. So if we have this point is 0.673, this point is 0.673. So we have this is tau 1 and this point is tau 2. Tau 1 and tau 2. So this is larger time and this is the smaller time, tau 1 and tau 2. For the differentiating the time equation, that is di by dt is equal to I0 minus et by tau minus 1 by tau. So this is I0 by tau e raised to the power minus t by tau, and that is I0 by tau is nothing but I minus IT I0 upon I0. So this cancel. Di by dt is equal to I0 minus I of t of tau. Or di by dt when t is equal to 0 is equal to I0 by tau. I0 by tau. So tau is again defined as I0 upon di by dt. I0 upon di by dt. Now the voltages across the elements L and R, that is VL is equal to L di over dt, that is L I0 L I0 di over dt. This di over dt is I0 upon tau e raised to the minus t over tau. This tau is equal to L by R. It is L I0 by LR e raised to the power t by tau. LL cancel. This is V0 e raised to the power t by tau. That is VL. So this Vt is equal to V0 e raised to the power t upon tau. This equation. And VR is R into IT. That is R I0 1 minus e raised to the power t by tau. That is V0 1 minus e raised to the power 2 by tau as current. As current. So this is decay. Decay voltage. And here it is growth voltage. This is decay voltage and here it is growth voltage. The equation, from this equation, we can plot the voltage. We can plot, this is VT. Here it is V0. Then this is the VR is equal to V0 1 minus E t upon tau. And this is VL is equal to V0 e raised to the power t by tau. So this is decay. And here it is growth. Growth of this voltage, this is 0 and here it is time. Here it is also time. So in this way, we have discussed about the total voltage remains constant. That is VL plus VR minus V is equal to 0. So VL plus VR is V, which is constant voltage of source. Constant voltage of source. Constant voltage of source during the transition. Now, these are the case when it is growth. The second is decay. Decay of current in LR circuit. Decay of current in LR circuit. LR circuit means this is the L, this is L, which is connected with the resistance R, and initially it was connected with the, this is 0.31. Initially it was connected from 1 to 3, then it was charged. Now it is connected from 1 to 2, 3 to 2. After some time, of the connection, three to 1, the connection three to two is made. 3 to 2 is made, and the Kirchhoff voltage law, and the Kirchhoff voltage law say VL plus VR minus 0 is equal to 0. So this is VL is equal to minus VR. That is L di by dt is equal to IR. That is di by I is equal to minus R by L dt, and integrating both sides, this implies log I E is equal to minus R L T plus A dash. A dash is constant of integration. This is constant of integration. So what we find here, it is equation 1, this is equation 2, and this is equation 3. This is equation 3. So from the equation 3, we have log I0 is equal to minus RL into 0 plus A dash when T is equal to 0, disconnecting point. Disconnecting point are switch off time. I is equal to I0. I is equal to I0. This is I0. So log I0 is equal to A dash. Log I0, putting it in above equation, we have log E base, all are E base, log E base I is equal to minus RLT plus log I0, log I0, E base. So log EI minus log EI0 is equal to RL by T by transferring this one. So this is nothing but log I upon I0 is equal to minus RL by T. So I0, I is equal to I0 e raised to the power minus RL by T. RL by T. That is IT is equal to I0 e raised to the power T upon tau. T upon tau when T tau is equal to L by R. Tau is equal to L by R. And also when t is equal to tau, I t is equal to I0 e raised to the power 1. That is I0 by e. That is I0 by 2.73. That is 0.368 I0. So IT is equal to 0.368 I0. Is the time tau, and t is equal to time. So we can define the time constant as this is the time when the maximum value E so this value is 0.368. There are two tau 1 and tau 2. Tau 1 and tau 2. So this can be stated as 36.8% of the peak value. This is IT, then peak value of the current. So this is I0, peak value of the current in the given time is time constant. And similarly, di by dt, this is your I, it is I0 e raised to the power minus t by tau upon minus 1 by tau. So this is minus I0 by tau e raised to the power minus t by tau di by dt. Di by dt. So VL is L di by dt, that is minus, this is L V0 by tau L by R and e raised to the power minus t by tau. And similarly, VR is equal to I R, that is R e raised to the power IR e raised to the power t by tau. So this is VR is equal to V0 e raised to the power t by tau. So these are the variation of voltage. So what we find here, we find that when there is a one component, that is inductor, other component is resistance connected into the DC circuit, then there is growth as well as decay of the current. The first thing, that is, we have defined transient phenomena. What is the transient? So transient is growth, switch on time, and switch off time. That is decay time, growth time and decay time. In between growth and decay, steady state. So there is no discussion at this moment, steady state. But we have to discuss about the transient state and growth and decay of the current in LR circuit. Along with we have discussed about the concept of time constant. Numerically मैं आपको बता दूं कि यदि ये ट्रांजिस्टर के रूप में स्विचिंग एक्शन हो तो वहां पर 60 नैनो सेकेंड और 80 नैनो सेकेंड स्विच ऑन और स्विच ऑफ टाइम होता है. Switch off and switch on time होता है. So time constant in the both way, switch on and switch off थोड़ा different होता है. And this is all about the today lecture. Now, on the next turn, I will like to discuss about the next part. So this is all about the lecture. So